Today you'll be learning lesson 5.6 on parallel and perpendicular lines. In order to complete this lesson, okay, we first need to review the different types of linear equations. Okay, so I want to identify what form these equations are in. So if you remember, this one, y minus y1 equals m times x minus x1. This is point slope form. Y equals mx plus b is slope intercept form. Ax plus by equals c is standard form. And again, y minus y1 equals m times x minus x1 is again point slope. Okay, the only one I don't have on this page is y equals mx, which we call direct variation. And the reason I didn't put it on here is because as long as you know the y equals mx plus b, the slope intercept form, you'll be good to go. But this right here is direct variation. So parallel lines are lines in the same plane. In the plane, we're talking about the same space, right? That will never intersect, okay? The thing you need to remember about parallel lines is they have the same slope, but different y-intercepts, okay? Down here at the bottom is your symbol for parallel lines. Line AB, this red line, is parallel by these railroad tracks to line CD. Okay? So anytime you see that symbol with what looks kind of like railroad tracks, it means parallel. Okay? So let's look at these equations, and we want to draw a line from equation in column A to an equation in column B that is parallel. So what we need to be able to look at is our slopes and our y-intercepts. Okay? So in this first equation, in column A, my slope is 2. It's really hard to see. My slope is 2. Second one, my slope is 1/3. And the bottom one, remember when you have x equals a number, we're talking about a vertical line, okay, which have an undefined slope, okay? Which means if I have a vertical line, it has to be parallel to another vertical line. So x equals 3 needs to be parallel with x equals 2. Okay? With any other type of line, they wouldn't be parallel. Okay? For our first one, the y equals 2x plus 4. Again, my slope is 2. So when I look at these ones over here, I need to find another slope of 2. So that makes the first one, y equals 2x plus 4, parallel to y equals 2x minus 4. Because they're starting at different points, but they're changing at the same rate. Okay? The second one was y equals 1/3 x minus 2. So when I look over here, it has to be parallel to the other one that has a slope of 1/3. So when you're looking for parallel lines, you're really looking for the slope and the y-intercepts. So, writing an equation of a parallel line. Okay, that want me to write an equation for a line, okay, that passes through the point -3, -1, and is parallel to the graph of y equals 2x plus 3. Okay, so since they tell me it's parallel, it means my slope has to be the same, but my y-intercept has to be different. So I know my slope has to be 2. And the other thing they told me about my line is that it goes through the order pair -3, -1. Okay? Which means I can write my equation in point, slope, remember, is y minus y1 equals m times the quantity of x minus x1. Right? Y stays y. What y1 comes from my equation. It's usually minus, but when I sub in that negative, remember, it becomes plus. So y plus 1 equals m, which has to be 2, so that is parallel, times the quantity of x minus x1, which is a negative 3, so it becomes x plus 3. So I wrote my equation, but the problem is that they want my equation to be in slope-intercept form, right? Which means I need my final answer to be in y equals mx plus b. So in order to get there, what I need to do from my starting equation is convert it to slope-intercept form, which means I need to get rid of my parentheses. Remember, we do that by distributing. So y plus 1 equals 2x plus 6. And then I need to get the y by itself. So right now, y is with plus 1. To get rid of plus 1, I subtract 1. And whatever I do on one side, I do to the other. Okay, so my final equation becomes y equals 2x plus 5. Right? And to check it, we can look at our slopes. Slope of 2, slope of 2, perfect. Y-intercept of 3, y-intercept of 5. They're different. So they're starting at different points, but changing at the same rate, which makes them parallel. The other part of the lesson today is perpendicular lines. Perpendicular lines are lines that are again in the same plane, the same space, that intersect at a right angle, okay, which means 90 degrees. Okay. The thing you need to know about perpendicular lines is that their slopes have opposite reciprocals. Okay? What we mean by opposite is positive versus negative. Okay? And reciprocal, remember, is the opposite of a fraction. So if I had 1/2, the reciprocal becomes 2 over 1, which would really then simplify to a slope of 2. Okay? If we're talking about the symbols for perpendicular, it is an upside down capital T, because in that capital T, we have those 90-degree angles. Okay, so that statement right there said line AB is perpendicular to line CD. And notice when they're writing them, they have that line symbol over the name of the line. And remember, when you name a line, it's named as any 2 points on that line. Okay, so that's what this red line would look like. And the blue one would have points C and D on it. Okay. So the slope of a line is 2. What is the slope of a line perpendicular to that line? Okay, so my current slope is 2. My slope has to be an opposite and a reciprocal. Okay, well, the opposite of a positive 2 means it has to be negative. And if my slope is 2, which is really 2 over 1, when I flip that, it becomes 1 over 2. So if I have a slope of 2, the perpendicular line will have a slope of negative 1/2. And that's what opposite reciprocals mean. They're different signs, one positive, one negative, and the slope is flipped in fraction form. Okay. So we have a line that passes through the ordered pair 1, 8 and is perpendicular to the graph of y equals 2x plus 1. What equation represents the line? Again, they want it in slope-intercept form. But what I know about my line is that it has to go through the ordered pair 1, 8. 1 over here. Okay? And right now my current slope is 2. And we've just done that one, so I should know that my perpendicular line needs to have a slope of negative 1/2. Opposite sign, so positive becomes negative, 2 over 1 becomes 1 over 2. So my starting equation is y minus y1, so y minus 8 equals m, when we have negative 1/2, times the quantity of x minus x1, which is 1. Okay? But again, they want me to do that next step of getting it to slope-intercept form, so I need to get rid of my parentheses by distributing. Okay? So I have y minus 8 equals a negative 1/2 x, and when I distribute that negative 1/2 to that negative 1, remember negative times negative becomes a positive 1/2. Okay, so I no longer have my parentheses, so I'm closer, but the problem is y is still not by itself, so to get y by itself, I need to add 8 to both sides. So then I have y equals negative 1/2 x plus 8 and 1/2. And remember, it's perfectly fine to have a mixed number for your y-intercept, just not for your slope. Okay. So how to determine if two lines are parallel is similar to determining if they are perpendicular. How are the processes? So to determine if two lines are parallel, what we do is we know that the slopes have to be the same. Okay? And that the y-intercepts have to be different. Okay? In order for them to be perpendicular, okay, we need to look at their slopes, and their slopes have to be opposite reciprocals. Either way, when you're looking at them for whether you're going to parallel or perpendicular, if you're trying to determine which one it is, more than likely your first step is going to be to get them in slope-intercept form. Okay? You can tell if your slopes are the same or not by looking at point-slope form, okay? But then you still need to be able to look at your y-intercepts. Okay? For perpendicular, you can leave them in point-slope form because you can determine if they're have opposite reciprocal slopes. Just make sure if it asks you to convert in your directions, you do the conversions. Okay? So are the graphs of the equation y equals 3/4 x plus 7 and 4x minus 3y parallel, perpendicular, or neither? Explain. Okay? So right now, I know the slope of this line is 3/4. Okay? I know the y-intercept. Pen is not cooperating today. Okay, well there's the 4. Okay? And that my y-intercept is 7. Right? But for my second equation, this 4x minus 3y equals 9, I cannot identify my slope for my y-intercept because it's currently in standard form. So my first step to determine this is going to be to get it to slope-intercept form, which means I need to get y by itself, so I need to get rid of a 4x, so I subtract 4x on both sides, leaving me with a negative 3y equals negative 4x, and again that x term goes first, so we want slope-intercept form, plus 9. Y is still not by itself, so to get it there, I need to undo this multiplying by negative 3, so I divide both sides by negative 3. Remember, when you do that, you really have two problems on this side. This is the other side for you. Okay? So we have this negative 4 divided by our negative 3. And we have this 9 divided by our negative 3. Okay, we have two separate problems. Right? On the left side, the negative 3's cancel. So I'm left with y equals. On the right side, negative divided by negative, it's a positive. And 4 over 3 doesn't simplify, so we leave it as 4 over 3 x. And then 9 divided by negative 3 is minus 3. Okay, so in this one, my slope is 4/3, and my y-intercept is negative 3. So to determine how they're related, we again look at their slopes. I have a slope of 3/4 and a slope of 4/3. Okay? Those slopes are not the same, so we know the lines are not parallel. Okay? But they are reciprocals. However, they are not opposites. Okay? This one is positive, and this one ended up being positive. So this is an example. These are neither. Okay? Because the slopes are reciprocals, but are not opposites. Okay, so they are neither parallel or perpendicular. So let's look at a real-life parallel and perpendicular problem. The architect uses software to design a ceiling. Okay, the architect needs to enter an equation that represents the new beam. The new beam will be parallel to the existing beam shown in the graph. The new beam will pass through the corner at 0, 10. So we know it's going to go through this point up here. Okay? Write an equation in slope-intercept form to represent our new beam. Okay? Now the problem with this real-life problem is they didn't tell me anything about my original line. So the first thing I need to do is calculate my slope. Okay, and remember, you can find that slope in lots of ways. You can use rise over run, okay, or you could use y minus y over x minus x. It doesn't matter at all which way you do it. Right? I'm going to choose y minus y over x minus x just for practice on that equation. Okay, but you can do rise over run if you prefer. Okay, so some points I know on this graph are 0, 8, and on this one, I know 12, 0. Okay, easy points to identify. 12, 0. So to calculate my slope, okay, I'm going to have y minus y, so 8 minus 0, over, start with 8, half start with 0, 0 minus 12. 8 minus 0 is 8, 0 minus 12 is a negative 12. So when I simplify that, they're both divisible by 4. Moving that negative to the top, I have negative 2/3. Right? Now they told me they want my line to be parallel, okay, to the existing beam. Okay, so the only thing I needed to find was actually the slope. I don't care about the rest of that equation. I could easily write it because I know the y-intercept, but I don't need to. I just need to write my equation in slope-intercept form, okay? Which means we, again, need it in y equals mx plus b, okay? Well, if we look at my information, I have a point, 0, 10, and I just figured out my slope is going to be negative 2/3 because for it to be parallel, the slopes have to be the same, okay? Now, I could go ahead and write this in point slope form and do the conversions like we have on the other ones. Or if you remember, when you have a 0 for your x, or when you look at a graph, this is on my y-axis. So I'm actually right away ready to write my equation in slope-intercept form. So the equation for the new beam will be y equals m, which is negative 2/3, x plus b, which we just found to be 10. Okay? So there's your lesson on parallel and perpendicular slopes. Remember, parallel lines have the same slopes, with perpendicular lines, the slopes have to be opposite reciprocals.